Our fourth unit is all on polynomials. So to begin our study of polynomials, we will look at monomials, because monomials are kind of our basic polynomials. So first we need some key terms or some words to look at. A monomial is a number, a variable, or a product of a number and one or more variables. Another way to think of it, it's the terms in an expression. So for example, if we have this expression, 4x minus 5y plus 7, there are three monomials. 4x is one of them. Think of this whole thing, because it's minus, as a negative. 5y is one, and positive 7, or plus 7. There are three monomials built into this polynomial. So, monomials just being the terms or pieces of just one thing. The monomials are always separated by a subtraction sign or an addition sign. A constant is a specific kind of monomial that is just simply a real number. So another way to think of it, it's a term with no variables. So again, looking at our example here, the only constant is this positive 7 or plus 7. This one would be a constant, this would be a y term, this would be an x term. Monomial rules, so things that are monomials versus things that are not. There can be no plus signs or minus signs. So this whole thing together, this polynomial, is not a monomial, because there are three pieces. Plus we can see, oh, right here is a minus sign, here is a plus sign. So that whole thing together would not be considered a monomial. Also, there can be no variables in the denominator. If it's something written along the lines of like 4 over x, whoops, let's go all the way. This is not a monomial because it has a variable in the denominator. So, a couple rules here to look at, especially involving exponents. Remember that whenever we're looking at an exponent, so some number to a power, this big number on bottom is called the base. The smaller number in the superscript is the exponent. So for an example, 3 to the power of 4 means 3 times 3 times 3 times 3. There are 4 3's being multiplied. The 4 means how many times being multiplied. The 3 means what number is being multiplied. So we have a rule for the product of powers. The exponent product rule tells us that when multiplying two powers that have the same base, you can add the exponents. In this example, you can see how it works. Adding the exponents is just a shortcut. So anytime you have x to the m power times x to the n power, it's the same as just saying x to the power of m plus n. So for example, 4 to the second power is these two right here, 4 times 4. And 4 to the third power is these three right here. 4 times 4, so 4 squared. 4 times 4 times 4. 4 cubed, or 4 to the third power. Well, how many 4's are there? 1, 2, 3, 4, 5. So we would just say it's the same as 4 to the fifth power, which is the same as looking at it as 4 to the power of 2 plus 3. So that's kind of a nice quick shortcut for us. Power to a power rule. I think there might have been a little mess up on yours. In your notes, they didn't have the parentheses. So what this means is x to the power of m, and it might make it a little more clear what they're trying to say. If you add in a parentheses here, to the power of n, x to the m power, that to the n power is the same as x to the m times n. So as an example, 5 squared, take all of that cubed, means 5 to the power of 2 times 3, so it's 5 to the power of 6. So let's use those rules in a couple of examples. Actually, we won't get to those rules quite yet. We're just looking at identifying monomials. So determine whether each expression is a monomial, write yes or no, and explain your reasoning. So for A, if it's just simply 23, we'd say yes, that there's only one term there, happens to be a constant term. but there are no pluses, no minuses, no variables in the denominator. So yes, that is a monomial. For B, we have f plus 23. This one has a plus in the middle of it, so we would say no. There are two terms here, f and 23, so you can tell by the plus sign or the minus sign that no, this is not a monomial. There's more than one term there. Same with letter C here. We have negative v plus 7. Because it has this plus right here, you would say no. There are two terms. There's a plus in between them, so this is not a monomial. Looking at D, there are no pluses or minuses, so no separation of the terms. We have a lot of variables on top in the numerator, but no variables in the denominator. So yes, this one is a monomial. No plus or minus signs, no variables in the denominator. This one would be a monomial. Same thing with E. We have 16 times A times B times C cubed. All of these just being multiplied together as one thing. There are no variables in the denominator, no plus or minus signs, so yes, this would be a monomial. For our last one, F, we have A times B, all of that then divided by C. Well, C is in the denominator for this case, so we'd say no, this is not a monomial. There is a variable in the denominator, so this one cannot be a monomial. Now is when we're going to get to use those powers. So we're looking at the product of power, so things being multiplied together. So rules for multiplying monomials. First rule, first thing you do is just multiply the numbers. So 5 and 2 in this kind of case. And your second rule, multiply the variables then. So variables times variables. Make sure the letters match. So first thing we would do is 5 times 2. Well, 5 times 2 is going to be 10. Next thing we'll look at is r's, our r1s multiplied by each other. Well, this one we have r to the third power. This one we have r to the seventh power. These are two powers being multiplied together. So r cubed times r to the seventh. Sorry, that kind of looks, there we go, r to the third times r to the seventh, which means we can just add 3 plus 7 here. So it's really, instead of r to the 3 and r to the 7, it's r to the 10th power. So we would call that 10r to the 10th power. This doesn't mean 10 is to the 10th power, it means r is to the 10th power. But this would be our simplified monomial then. In this case, if there are no numbers that go along with this, then there's kind of a hidden number 1. So when we start off with our numbers, 3 and, oh, there's no number here, it's like a hidden number 1. So 3 times 1, our number part would be 3. Now we look at multiplying our variables together. C times c to the 4th. If this is just c, we think of it as, I'm going to do it down here, c to the first power. There's only one c being multiplied here. So c to the 1 times c to the 4th power, this 1 and this 4 being added together. So in the end we would call this c to the 5th power. So we have our number part, we have our c's. Now we need to do the d variable. We have d to the 2 and d to the 3. Well, 2 plus 3 is going to be 5. Nice quick shortcut there. So this monomial times this monomial will end up being, whoops, 3 c to the 5 d to the 5. Again, we have our number part, so 3 times 7 is 21. There's only one variable in this case, z, and another z. So we know it's going to be a z. What power should we go to? Well, we have a 4 and a 5. All of this is being multiplied. 4 plus 5. Remember, those are just added together. 4 plus 5 is 9. So 21 times z to the 9th. This would be our new monomial. And last one here, number part, -4 and -5. Remember, two negatives make a positive. 4 times 5 is 20, so it's now a positive 20. Start with our variables a and a. Remember, this is like an a to the first power, a to the 1. 1 and 5 will add up to 6, a to the 6th power. B, again, like to the 1, and b to the 3rd power. 1 plus 3 become b to the 4th power. And c to the 2nd, and c, in this case, to the 1st. 2 and 1 makes c to the 3rd power. This would be our new monomial. This monomial times this monomial would be one new monomial. All right, now we're looking at power to a power rule. So we have 3 squared, and there are 3 of them. That whole thing is cubed. One way you can think of this is it's 3 squared times 3 squared times 3 squared. There are 3 of them, 1 here, 2 here, 3 here, because we have this cubed on the outside, or this 3 here. So if we're thinking of things as power times a power, well then 2 plus 2 plus 2 equals 6. So we can say 3 to the 6th power. A quicker way to do that, though, find the same answer, 3 to the 6th power, is if we started with our base of 3, and 2 times 3 is 6. 3 to the 6th power would be a simpler way to say that. Same thing with b. We have a power to a power to a power. Notice that there are extra brackets here, extra parentheses, so we have to do one at a time. So we start off with our base of 2, 2 to the power of 2, to the power of 3. Well, 2 times 3 is going to be 6. So we'll start off with looking something like this, 2 to the 6th power, all of that to the 4th power. Now we have 2 to the 6th to the 4th, so we have to do 6 times 4. We would get 2 to the 24th power. And that would be our final answer, 2 to the 24th power. At this point, I want you to pause the video and try this one on your own. 2 to the 2, all of that to the power of 2, all of that to the power of 4. See if you can figure that one out. Pause it, give it a shot, then push play again and see if you can figure it out before I do. So now that you have unpaused your video, 2 to the 2 to the 2 to the 2nd power would actually become 2 to the 4th power. 2 times 2 is 4. We have all of that still being to the 4th power. Now 2 to the 4th, take that to the 4th power, means then we have 2 as a base. 4 times 4 is 16. 2 to the 16th. So that would be your final answer. Example 4, we're looking at simplifying expressions. So rules for monomials to power. So in the previous examples, we were looking at just one number to a power. Now we're looking at a whole monomial to a power. So one thing you need to note is that each piece of that exponent goes to this power. So this exponent 2 gets applied to each of these pieces, this y cubed, this x, and this 4. So before we even look at this one, we don't need to look at that yet. We have to change this piece first. This 2, like I said, goes to each piece. So we have a 4 squared. We have an x squared. And y to the 3rd to the 2nd means y to the 6th. Now 4 squared, we can figure that one out. 4 times 4 is actually, we'll call it 16. So it's 16x squared y to the 6th. So we figured out the first part. Let's look at this second part then. 16x squared y to the 6 over here. Before we can even look at that cubed part, we need to apply this 2, or squared, to each of these pieces. We have a negative 2 that we're starting off with. Well, negative 2 squared, negative 2 times negative 2 becomes positive 4. Y squared becomes y squared. So we started off with just that piece. Now we need to put it to the third power. So all of this to the third power. So again, we can apply the 3 to each of these pieces individually. Call it 4 to the third power. Y, instead of just to the 2, it's to the 2 times 3. Y to the 6th then. And 4 to the third power, so 4 times 4 times 4, is actually going to become 64. So at this point, we've changed our expression into being this piece right here times this piece, which is now here. So now we just do multiplication of our monomials like we did before. 16 and 64 became 256. Oops, sorry. Did that too quick. It actually becomes 1024. X, and oh, there's no other x's here, so it just stays as an x squared. Y to the 6th, and another y to the 6th become y to the 12th. So A, this whole expression becomes 1024 x squared y to the 12th. One big expression. Before going on to C here, I'm going to go down to B. We'll look at B here. Just like in our last one, we have to apply this 3, or cubed, to each piece individually. So negative 2 cubed, so negative 2 times negative 2 times negative 2 stays as a negative 8. The negative doesn't cancel out because there's 3 of them, not just 2 of them. A squared, and then to the third power becomes a to the 6th. B squared, and then to the third power becomes b to the 6th. So this piece becomes this green piece right here. This piece then, negative 4b, all of that squared, and then all of that squared. We have to look at just this inside part first. Negative 4b squared. So we're kind of ignoring this one. Well, negative 4 times negative 4 is positive 16. B squared, so b times b is b squared. And we have to put that squared back on the outside here. So 16b squared squared. This part, 16b squared squared, the 2, the squared has to go to each of these pieces again. 16 squared becomes 256. B squared, and then squared, becomes b, whoops, b to the 4th power. Now we've got negative 8a to the 6th, b to the 6th, times 256 b to the 4th. So now we can just match each of those things together like we did before. Number times number. A's with the a's. Oh, there's no a's here, so it'll stay the same. and b's with the b's. Negative 8 times 256 becomes 200 or 2048, a to the 6th, and none of them over here, so it just stays as a to the 6th, b to the 6th, and b to the 4th. Oops. Become b to the 10th. Just make sure it's a superscript. 10th here. So this would be our new expression in the end. One step at a time. Now, going back to this one. The area of a circle is pi r squared. That's the formula for any time you have a circle. Pi times the radius squared will be your area. Now, what if we knew that the area, or the radius, was 2 times a times b squared? So they didn't give us an actual number, they gave us another expression. Well, we'd have to plug this expression in for r. So we would say then it is pi, instead of times r, it's times 2ab squared. Instead of r being squared, it's this whole thing being squared. So we know our rules. This squared, this 2, has to go to each of these pieces. Pi will stay as it is. This 2 squared becomes 4. This a squared becomes a squared. This b to the 2, or b squared, and then to the 2nd power becomes b to the 4th power. Now, normally when you write answers like this, you always want your number part out front, and then we can leave things in terms of pi. So we'll call it 4 pi a squared b to the 4th. So this would be our final answer. And that'll do it for our first video.